Assalamualaikum warahmatullahi wabarakatuh. Thanks for the opportunity for me. My name is Taufiq. I will present our paper about the result of arsenic gas distribution to determine a heat source at geothermal research system. This is research part 2. On the previous result, we try on a different geothermal area. This is my biogeography. I am from the Research and Technology Center of Pertamina. In this day, I will present our paper with the 6 points. The first is previous research result. Second, introduction. Third, theory for acquisition, result, and conclusion. In the first point, we present about the previous research result. In the first geothermal area, we get the value of arsenic gas acquisition on first geothermal field validation with range 75 until 300 nanogram of arsenic. In this value, we make the hypothesis. We correlate the value of arsenic gas map with the subsurface temperature map based on the well of the data. The first hypothesis, we resolve the height of concentration of arsenic gas with range 75 until 300 nanogram arsenic is same as the height of temperature on well data with range 250 and 278 degrees Celsius. It shows a positive correlation of the both of the data. The second hypothesis, we correlate about the arsenic gas with range low until 0 point on the area of injection well. It causes the low of temperature on the well is different of the water injection to dissolve the arsenic gases. Based on the previous result, we make the 4 point, the focus point on the result part 2. The first, we must know the character of the arsenic gas is volatile and can release on high temperature, and arsenic can dissolve on water with low temperature. The second is we correlation about the high concentration of the arsenic gas with the production zone on geothermal system. And the third point, we must classify the range of arsenic gas value to show the impurity of the source gas, what we come from the hot source on the different source. Therefore, we must know the depth of the penetration of the arsenic gas on the result of the arsenic gas. Why we choose the arsenic gases? The arsenic gases is a heavy metal element on Earth's crust. It's volatile element we can only release on the high temperature, and arsenic gases is associated with the temperature, high temperature. We can see the left side of the presentation. The schematic of the arsenic gases shown on the surface with the volcanic activity. So, based on the reference, we know the arsenic is carried by the third of the schematic. The first is magmatic, hydrothermal, and chemical. The arsenic is carried by magmatic fluid, which reaches the surface with fault. It from the Bonomo and Pitler 2014. The arsenic can carried by hydrothermal fluid in interact with igneous rock from Mahapatra 2007 and Webster 2005, and arsenic is carried by chemical compound pesticide used by human agriculture. Is from Bonomo 2014. Based on this reference, we assume the arsenic gas can identify the distribution of hard source of geothermal system. So we run the data acquisition on the second geothermal field with the 250 point of acquisition. The area is 6 to 11 kilometers square, and the distance per point of the acquisition is 500 meters. We we put the arsenic gas instrument acquisition on the vacuum condition, and we observe 14 days uh, the gas on the on the on the subsurface on the surface, and then we we make the distribution of the arsenic gas is classified in the high value with the 50 until 170 nanogram of arsenic. And the second, we classified the arsenic with medium value with 10 until 50 nanogram of arsenic. So based on the data, we make the map, arsenic distribution map, to describe on or the hypothesis on the previous research. In this map, we we show the first hypothesis. The arsenic is a correlation with the production zone. We can see the zone of arsenic 3 is we have height of concentration of arsenic is a positive correlation with the subsurface temperature map with value 200 degrees C in the central of the map. We can see the zone of arsenic 4 is same. We have the height of arsenic gases with value 50 until 170 nanogram of arsenic is correlation is a positive correlation with the height of temperature with 200 until 270 degrees Celsius. So in this map, uh, we show the hypothesis, the two hypotheses show the arsenic is dissolved of water injection. We can see in the north of the map, we can see the value of arsenic is low until a 0 point in there. It shows a positive correlation with the injection well. But we have an interest zone on the zone of arsenic 1 and the zone of arsenic 2 in this map. The zone of arsenic 1, which have a height of arsenic gas distribution, but in there we don't have the manifestation point. It seems as a zone of arsenic 2 in there have a height of arsenic, but not have the manifestation point. But from the geological map, from the reference, we know the arsenic 1 and arsenic 2 is controlled by the volcanic mountain. In the zone of arsenic 1 is controlled by the Wiranda mountain, and the zone of arsenic 2 is controlled by the Putri mountain. But we have the interzone in the zone of arsenic 5. In there, we have the height of arsenic, but once again, we don't have the manifestation point in there. It describe who atau what we have the high temperature on there or not, but we don't have the data of a subsurface temperature map on the zone of arsenic 1, but we try to interpret that the zone of arsenic 5 is the zone with the hidden prospect of the geothermal system. So based on this research, based on the data and based on the map, we conclude the first is based on geochemical acquisition of the arsenic gases with range 30 until 150 nanogram of arsenic is indicated of the high temperature rock or a steam zone or the head source area. 2, we validating with subsurface temperature map in this area. It show a positive correlation between high arsenic gases with high temperature map. And third, we combine the results of the validation 1 and validation 2 in this research. We conclude first, hypothesis number 2, the arsenic gases is dissolved on the water of low temperature. It's a validation with injection 2. And hypothesis 1, the arsenic gases is a correlation with high temperature. And this method and this instrument can be used to help a preliminary survey in the hidden geothermal prospect area. So this is from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.